Good morning, everybody. My name is Carlos Perez. The title of this session is Cracking Activity and Abuse of PowerShell. So yesterday, most of you probably were at Daniel Bohannon's presentation where he was covering how they threat hunt and look for attackers, and specifically what attackers are doing with PowerShell from the defensive side, from the blue side as we call it. Well, on today's session, I'm going to be covering from the red side, from the other side of the coin, practically. So on this session, I'm going to track a bit on how I perform some actions and how you can track those actions that I'm doing, how is it actually being abused, and some of the principles on how to track that usage. There's specific hints that you will see in event logs that correlate to multiple techniques that we can do. And what I really want you to get out of this session is that typically, sorry about that. Typically, when we do attacks, we think in chains, typically. So we're chaining multiple steps, multiple attacks, and I want you guys to actually see with me what are the areas that where all of those different chains all of a sudden kind of consolidate into 2 or 3 specific things or areas that you guys can monitor to be able to find my actions inside of your network. Or at the very least know that, hey, Carlos is doing something funny in our network. So for those of you who do not know me, I go by the handle of Dark Operator. I work at TrustedSec. I'm in charge of the research team at TrustedSec. And my main job is writing offensive tooling. So my main job is, in the case of Daniel, he writes detections. In my case, I write ways of bypassing his detections. So I can emulate nation-state hacker or criminal organizations. So I'm constantly looking at threat intel feeds, information out there on how bad guys are doing stuff. And then I add all of that stuff into our tool so we can emulate them. And many times people tell me, hey, why should I be monitoring PowerShell? Well, here we have very good examples. Oh, PowerShell threat grow further, the rise of fileless threats and abuse. And the funny thing is that all of that stuff is people that don't have your smarts. And let me explain why. 90% of all samples that I see with PowerShell out there normally is droppers, or as we call them, cradles. That was a term invented by Matt Graber and Chris Campbell. Chris Campbell has like 6 kids. So I think one night, just without sleep, he was going like, oh, I grabbed my payload and I need to put it somewhere and cradle it and protect it. And he went like, cradle. And he had his kids in cradles, and we're like, oh, this is a nice idea. So typically what we refer to in our lingo as cradles is just a piece of code in PowerShell that will use regular .NET. And it's kind of funny because the PowerShell is never the main entry point. It's rarely the main entry point. If you see, in fact, to be honest, I've never seen PowerShell be the main entry point into your systems. And then when you talk with security people, they go like, oh, we got to block PowerShell. And you're like, oh, do you block macros? No. We have macros enabled for everybody. It is a business need. And I go like, how large is your organization? 2,000 people. How many of them need macros? Oh, the finance department. How large is the finance department? 2,000? No, only 5. But you want to block all PowerShell across all systems, you lose that tooling, but you enable macros for everybody and only 5 people actually need it. So we see kind of that logic many times, and I want to dispel some of the myths on it. So typically when we just flip a hand. So typically, believe it or not, at this day and age, the main way that we get into systems has been the same way we have been doing it since the early 2000s. Or if you're like me, I've been doing this since 98. So one of the things that you're going to be seeing is that most attackers still get into systems via macros. They still work. HTA files. I remember when Microsoft in Windows 98 released HTA files. And then my team back there working for the government went and we wrote our first piece of malware using BB script and HTA files around 99, 2000. And to this day, it works the same way. More than likely, if I can find one of those old zip drives, zip disks from back then, and I'm able to put it in my machine, and I grab one of those payloads, they will still work. Thankfully to backward compatibility inside of Windows. Then we have link files, LNK files. What are they? Shortcut files. As simple as a shortcut file in a zip drive. In a zip file, send it over, people will double click it, it will run my command with the parameters that I want, and it works. So was my main entry point PowerShell? No. Are you looking in your emails for link files? Probably not. Are you looking for HTA files? I've gone to many organizations and asked them, do you have a profile of HTA files? And they go like, no. And we go into the SIM and we look at the entire list, and the only time an HTA file was ran was when our target double-click on it. And go like, you have an outlier there. You have some basics that you should be covering. And we have click once files, and believe it or not, people download and execute stuff. We just convince them that they need to execute an executable for us. A great example. I'm not going to throw the client under the bus, but this happened many years ago. We were engaging into a bank. We sent them a file. The antivirus actually triggered on our payload. And the antivirus says, oh, this is malicious. And it went into quarantine. The user took it out of quarantine, took it out of the zip file, double-clicked it again, and it got caught again by the AV. The user went again into quarantine, removed it from quarantine, whitelisted the executable, double-clicked it, and we got shell. So users are that way. We don't have to go with very complex schemes on how to do this type of attack. So let's look at some of those attacks right now. So here's an HTA file. For those of you who do not know what an HTA file is, an HTML application. In fact, when Microsoft released this, it was initially used for control panel objects. And we still find environments when there's this guy almost my age in his 40s that grew up with BBScript, JScript, that do everything with HTA files. They're very rare, but we do find quite a bit. So one of the things that we're going to notice on this HTA file is our HTML application. It describes stuff. I can run JScript. I can run BBScript. So I can make it functional. This actual HTA file was used in one of our social engineering campaigns. There was this target site that accidentally exposed their DNS server for Active Directory to the outside world. That doesn't happen, right? No. It happens quite a lot. So we went in, we did, all of a sudden we were going into the server sets, and as part of our tool set, there's a Python tool that I wrote called DNS Recon that automatically checks for SRB records. And all of a sudden I was doing a scan, we had all of the DNS ports, 53 open in the target network, and I started just running DNS Recon on each one of those for the domain of the target site to see if we can find one DNS server, probably for QA, for testing, because many times people expose the DNS for testing and QA, and they put way too much info on them, and sometimes zone transfers, they still work. And all of a sudden, I see SRB records for AD coming back. And I'm going like, ooh, KDC, LDAP, and I'm going, oh, this is bad. I hope it is test. And I look at the IP address, the IP address was 10.10.1 something. And then others were 10.9 something, and you're like, oh, this is a class B on 10. So I went like, let me see if I can do reverse lookup. And I did reverse lookup on the target environment, and I was able to get their entire IP address space, and all of a sudden I was seeing HSRP node 1, HSRP node 2, Sally help desk, Austin office, second floor, and the naming of the computer. So all of a sudden I have an entire view of the physical infrastructure of the target just via DNS. And I'm like, awesome. So what I did is I called Sally. And I called Sally and it says, hey, Sally, you're the user of computer, blah, 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 blah. And she goes, yeah, that's my computer. Oh, and you're using probably printer so-and-so? Yes, I'm using that printer. Yeah, my name is so-and-so from the help desk. We're seeing issues with your machine. Can you please confirm your email for me? Your email is this one. No, it's not that one. It's this other one. Okay, let me send you a link to a file that I need you to run that will provide me diagnostic information because we're having some issues in your building. Can you really help me? Right now, I need to get to my daughter's recital. I'm a bit late. I don't know if you're a mother. Yes, I'm a mother. I totally understand. So we start pulling those emotional strings on the target as we're moving. And I send her the HTA file. And all of a sudden, when she double clicks that HTA file, let me go here. Support information collector. This is what she gets. And that's the information, and she clicks submit to support, and I go like, oh, thank you, I got all of the information, but what's actually doing in the background, this HTA file, which looks benign, is I'm running this script block. Script, JScript, ActiveX object, wscript.shell, run Windows cmd.exe, powershell.exe, and all of a sudden I'm writing powershell.exe with whatever command I want, with 0, which is hidden, so you don't see it. And I know. There's this thing called AMSI, and AMSI is going to see it, and AMSI is going to trigger on it, and it's not going to let me run it. So I need to bypass AMSI, so AMSI will let me run that command, because AMSI now detects JScript and BBScript. So let me bypass AMSI. Okay, bypassed. What happened there? Well, you see, HTA files are a very old technology in Windows. And when Microsoft team added AMSI support for Windows scripting hosts, they did it for BBScript, JScript. But on an HTA file, once I remove JScript from that tag, it uses the IE JavaScript engine, which still supports ActiveX for backward compatibility for most environments. But AMSI doesn't work with the JavaScript engine of IE, because what would happen in that case? All of a sudden, I'm going to a modern web page, and now the entire page is just waiting for the AV to say, this is okay, this is okay, this is okay. So performance would be so severely impacted that it doesn't make sense to add AMSI to that engine. So it was never added. But as attackers, we can easily bypass AMSI that way, and we ran PowerShell. And you're probably going, oh, that's easy to track, Carlos. We can track that easily because you're running a command, and you're right. Right now, the main way for you to track PowerShell execution is to use process auditing. Process auditing will actually tell you, hey, this executable happened. Now, one of the problems or things that I don't like about process auditing inside of Windows, it was that when it was designed many years ago, it was designed by an engineer. What do I mean by that? When you will look at PIT and parent PIT processes, everything is a hex value. So all of a sudden you're trying every other tool out there, WMI, everything else, gives you a binary decimal value of like 1, 2, 3, 102, something like that. And you get that PIT and parent PIT, what is the parent process that executed, to be able to track. And then one thing we learn very quickly is that as an attacker, I can abuse that with short-lived processes. So one process dies, it changes to another, then it's changed to another, because Windows changes PITs very quickly. In a matter of seconds, I kill that process, and I start another one, and it may be using another valid PIT. So PITs are not that good for tracking. So Mark Rusinovich came with Sysmon. Sysmon improved that. Now I have decimal values, but in addition to that, now I have a unique GUID to be able to track that. So as an attacker, one of the first things I'm going to check is, are you running Sysmon on that target box? If you're running Sysmon, is going to change the paradigm on how I work. So just to give you an idea how I work is that once you click that HTA file and executes my payload on your target, first thing I do is I do what I call situational awareness. Under what process am I running? Under what privilege am I running? Under what user am I running? What is the OS? What is the architecture? Because that will determine a lot of tools. Let's say if I land inside of a Windows 10 box, and more than likely it will have .NET 3.5, .NET 4.5. It's going to be available. I'm going to be able to use .NET. PowerShell is going to be more than likely 5.0, 5.1, depending on the build of Windows. x64, that means I can use x64 payloads. I don't have to go with the x86, which there are even more signatures for. So that gives me an idea, and then I do a threat assessment. I look at all of your processes, all of your services, install applications, and then I'll go, okay, what is he running? What are the controls in the system? Because that's going to tell me as an attacker two things. Thing number one, what tools can I use? Because they're going to be limited by what you can detect. And the other thing is the tempo. How fast can I move in that box, in that environment? Because the more controls you have, and the most stuff that I see that you guys have your act together, the more security mature you are, the slower I have to go. And the less risk I have to take. I cannot be risky trying stuff out. I gotta be very, very careful because I can just determine just by looking at processes, services, and some basic controls how good you are in that environment. So, how does that look? So all of a sudden, we're here in your environment. I sent you a document. Let's see, I have benign macro here. I need malicious macro. So all of a sudden here I have a box running Metasploit. And Metasploit, I have a listener listening to it. For demo purposes, I have them in the same network. Typically what we would do is we would create a bunch of fake domains and we'll have multiple servers to one single database with a bunch of proxies in between. So as you're detecting my C2 and killing it, I'm able to pivot to other C2s and be able to play the cat and mouse game with your defense team. But for demo purposes, I'm only having it from one machine to another. So it's listening here on port 8443. I sent you a macro. You double click on the file. I can trick your users into clicking this. And all of a sudden, boom, I get a shell on my system just by you opening that document. And you're probably going, look, my users, I've taught them. They've gone into all kinds of training and they're not going to do it. I'm going to tell you a trick that I used when I was doing internal red teaming. We created this ruse. We found out that one printer, we were not able to get access to any of the machines because everybody enabled firewalls on their machines. And believe it or not, that is rare. There are environments that, I don't know why they disable the Windows firewall because they go like, oh, it's easier to disable the firewall than just to push rules, and they disable them. But this, in our environment, we actually had it enabled, so we were limited in lateral movement, so we only got access to a printer. We look at the printer, and the printer actually told us about an internal SMTP server that didn't require authentication, so we could send emails to appear as if they were from the company internally, and there were no checks. So no DKIM, no checks at all that would have detected our phishing campaign. So we make a fake email as if it is from HR, and we call it executive pay raises. We put it into a zip file with our macro, and we encrypt the zip file. We put a password, and we include the password in the body. Hi, this is the pay raises for you executives for the next quarter. Thanks to what we have achieved right now. Blah blah blah. Here's the password. If you guys approve of these raises, please get back to me in the next couple of days. We send that out, but we know that because we're part of the organization that they know what a ruse looks like. And then we count to 10. 1, 2, 3. And on the number 10, we send another email with big red letters. Warning! Do not open that document. The information contained in that document is confidential to the company. Please delete this email immediately. It was sent by error. And we got 80% click rate. 80% of the users were like, ooh, click it, enter the password, double click it, enter. Come on, let me see. And we even had fake information. Some people actually got mad and sent emails. How are you supposed to be getting such a high pay raise? This is not just to all of us employees, blah, blah. And it worked like a charm. And so macros worked. I got my session. And one of the things that I want to do in the case of PowerShell is I want to know what you're running in your environment. So I can do use post Windows gather enum psenv set session to 4, and I run it, and it was going to check the machine for the controls. So what it's actually doing is what I told you of doing a threat assessment. What are the controls enabled in that machine? So all of this is running in memory. I'm not running any other executable on the target box. And what is actually happening is telling me, hey, ScriptBlock Logging enabled. PowerShell version 2 engine enabled. Oh, I can bypass AMSI, I can bypass other stuff. Awesome. It's telling me all of the modules and snap-ins that this user has on his machine. And there's a good reason why we look for this. Because typically we hunt for admins. So how many people here are admins? Okay. How many here use Azure, for example? We're Microsoft people. Awesome. You use the same machine to administer Azure that you use to receive your emails? Okay, awesome. I like this crowd. You use virtual machines. In fact, nobody raised their hand. You have separate systems. Many environments actually use the same machine. So we hunt for you guys. And one of the things that we hunt is for the Azure modules. And then we're looking for that Azure authentication token that is protected via the DPAPI in your machine. But since we're running on the same context as you users, we're able to decrypt that token without any problem. And all of a sudden, I can become you, the Azure admin in your environment. And since I'm in your machine, I can pivot through your machine so you never get an alert that you're getting a connection into Azure from another region or another place. I'm just using your machine as a proxy to connect back to Azure, to bypass those nice controls that Azure has. We got bitten by it very quickly when Azure pushed that all of a sudden we connected, we got the key, we copied to our machine, and we got, so we have the keys to the kingdom. All of a sudden we connect, and then the admin gets an alert, hey, somebody's connecting from this region, is that you? And they went like, no. And they quickly changed everything, and we lost access. We're like, crap. So we adapted our TTPs to it. So now I know what you're running, what version of PowerShell, what modules you have on the machine. But how does this look in the event log in the case of processes? I'm sorry for the resolution. Fusion is not cooperating with me, but I'll use Submit to go here. So if I go to process creation, which is, there we go. All of a sudden I was nervous. There, let me find the process. Search profile. I waited too long. Yeah, I talked too much. Yeah, there we go. There we go. Typically I go in details. Let me make this bigger here. So does this look familiar for those of you who were in Daniel Bohannon's presentation yesterday? So I'm using a stream reader ever since JSEPT, and it's executing on the target box. And believe it or not, still works in many environments. The only thing we have to change is a bit the code. And this is just a simple payload that runs in your environment. So now you have some visibility. At least you know that PowerShell ran, and you can have rules just for those command lines to be able to identify it. That's your first line of defense, process monitoring. That will give you quite a bit of info. Sadly, when it comes to parent process and all the other type of information, this becomes a bit hectic when you're doing hunting, and that's when typically I recommend people just to use Sysmon for process creation. Because one of the things I like about here we go. Sysmon is actually, as I keep executing PowerShell again and again, going deeper down the rabbit hole, it is actually just showing me the entire code. So at the very least, if they're using command line, I'm able to keep looking and looking as that base 64 then turn into this other one. And I'm, what are those Russian dolls that you keep opening and getting into another one and opening to another one? Well, Sysmon allows me to, at least if everything's command line, just to keep going like that. And I'm getting the parent process, and everything's a GUID. And that GUID is unique to that machine, unique to that process. And then the parent process also has a GUID, and there's a hash, and I'm able to do more effective hunting to find the attacker. So when as an attacker, when I see this, I worry when I see Sysmon on a target box, because Microsoft doesn't publish the schema of the Sysmon configuration. So in the registry, that binary blob, I just know it is there. So I need to go to extra steps to extract that, get it back to my machine. And if I'm able to run a sysadmin or in your box, I can actually neuter Sysmon. So what I do, I just go to that registry where the rules are there, I delete that, and all of a sudden, Sysmon says the registry key changed, and I'm going to reload, and I'm not going to add an event for configuration change. And those of you who know Sysmon know that every time you make a configuration change to Sysmon, Sysmon records an event, configuration got changed. But if you delete the registry key, since the change was not done by sysmon.exe, no event gets recorded. And the configuration goes back to default. Or if I push a configuration into the registry key, my own configuration that says, don't monitor anything, and then I set the exclude or the includes however I want, Sysmon will automatically get that configuration. I just blind it. So typically one thing I recommend is, as you're adding controls and you're adding tools like Sysmon and stuff, protect the tools. We go after those rules. Put DACLs on those registry keys. Obfuscate it a bit. Many times we move quickly, or we have to move quickly because the engagement, let's say, red team engagement, a month, 2 months, and it took us, let's say, a month to get in because you're that good. You have very good controls, and it took us a long time to get in. Once you get in, all of a sudden we're on a time constraint and we need to move a bit quickly. And if you change, for example, the driver names and other stuff, that means that we have to up our tempo of operation and bring other tools that will be more noisy that you can detect. So the more protections you can add, the better. So protect the Sysmon key so I'm not able to abuse that in your environment. So let's go back here. Now, moving away from process listing, one of the events that I really like you to focus on is an event 400 and 403. And you're going like, Carlos, that's not ScriptBlock logging, that's not module logging, that is not transcript logging, that is not the new hotness, that's old stuff. We have that since PowerShell version 2. The thing is that if you know where to look, you can find what you need in many environments. So all of a sudden I was talking with Daniel, and we were going through multiple scenarios. Me from the red side, him from the blue. We're bunking together here for the conference. So during the night, all the way until 3 a.m., I was going through my slides, and we were going through scenarios and stuff. And he was noticing like, oh, I didn't notice those unique values in 400. They do differ. Because 400 is the engine state. Every time I create any PowerShell, be it from C++, if you like pain, be it from .NET, C#, BB, F#, whatever, or even if it is unmanaged PowerShell, there's always a RunSpace being created. And that RunSpace is always getting logged in an event 400. Even if I downgrade to PowerShell version 2, even if I'm running the latest version, that RunSpace is always there, and that RunSpace actually has some very nice information. So typically, in a normal environment, also if you're running PowerShell version 5, you're going to see this. Console startup, 4961, RunSpace ID, then you see another event, 53504, name type IPC for controlling that PowerShell service remotely, and that service has the same RunSpace ID, and then we see, as we end up and we close our session, we see a 4962. But what happens when I run managed PowerShell, which is I'm injecting enough of the CLR into memory to run PowerShell and everything? The only thing you're going to see is a 53504. The other two disappear. So what I want to get is for you guys to look for those outliers, to look at the patterns and act on them. Not only on the content of the logs, but how does that pattern of attack, that pattern of actions actually look at? So by me trying to be a smartass and try to load everything in PowerShell version 2 and do a managed PowerShell, all of a sudden I created an IOC that you guys can track very, very easily to find my actions in your environment. So let's look at some examples on how we write our tools for this. Let me go here into Visual Studio. So this is the first one. This is just C++. A lot of people actually do not know that you can do PowerShell in C++. And it works. You can load enough of the CLR in C++ as you're coding it, and then you can add PowerShell into RunSpace. It behaves almost the same way as C#, but it is C++. So if you like pain, hey, some people like it. I don't judge. They do it that way. And you can actually run enough of the CLR, it will run in your machine, it will launch PowerShell, and PowerShell.exe never got executed. Also, if you want, you can do it via C#, and you can be a bit smarter when you do it via C#. So here in C#, what I want you guys to focus here is on this. When I'm creating my PowerShell process instance, what I'm doing is I'm specifying the version of the engine. I'm saying, no, buddy, when I run PowerShell, I want you to be PowerShell 2.0. I don't want you to use the latest because I want to bypass all of this stuff. So all of a sudden, I'm starting PowerShell, and ScriptBlock Logging, module logging are not going to be there, but that event 400 is. And you're going to be able to track my actions via that event 400, and you're also going to be able to track my information via just looking at the process monitoring, because, yes? If you have the PowerShell version 2 disabled, that will not work. The problem is that in many environments, the PowerShell version 2 engine is included, and many times we see defenders that go like, most of the malicious .NET, because now we're moving to .NET, most of our tools, that you guys are writing, you're going lowest common denominator because you're using .NET 3.5. And the thing is that, thankfully, Microsoft is so nice that every time you install Office, it requires .NET 3.5. So if you have an environment with Office, .NET 3.5 is not included in Windows 10 anymore, but you install Office, now you have it. And then we can abuse from there. So let me look for my executable here. Where is it? Console PS. This is the one that will run PowerShell. Got that. This one will run PowerShell version 2. Take the actions and close. Now if I go here into the event log, and I go PS Lifecycle, event 400's here. If your entire environment is Windows 10, you should not be seeing that field there, engine version 2.0. There's no need ever for there to be an engine 2.0 if everything that you're running is Windows 10 and you're running the latest and greatest. Also, in this case, is remoting's not enabled on all of my clients. Why do I have server remote host? Remoting's not enabled. Why do I have a version 2 and then remote host? Because what is actually happening if I look at process logging is I'm starting PowerShell engine as version 2.2, and then via name pipes, I'm controlling it and passing all of my commands and executing them via name pipes directly via memory, via the IPC. So all of a sudden you're looking for the command, for the command line of my commands, they're not there. I can show you that. Let's look at the other one that I ran via C++. This one, all of a sudden, you see console PS here executing. It executed latest version, but it is default host. It is not console host. And it's just those small details that will get a red teamer and attacker caught as they're moving to your environment. So do look deeper into that information. And just in case, if you want to look at the process information, process create, I'm going to look here for PowerShell. Bless you. Here we go. Let me go detail view because it's going to be a bit bigger in XML view. As you can see, all of a sudden I'm running PowerShell.exe version 2.0 -s, no logo, no profile. It's loading into the environment, and then I'm controlling it remotely. You don't see any of my commands there. The get process and the get services commands that I run. Because why am I controlling that session? Internally via memory. Why? Because I know you guys are looking at the command line. So I want to bypass that. But if you're running an environment which is homogeneous Windows 10, we should not see TAC version 2 there, unless you're a SharePoint admin and you're running an old version of SharePoint. And if you're running an old version of SharePoint, you do like pain. So we're here. Let's continue. I want to make sure I can make it in time. Now, let's say we have ScriptBlock Logging enabled in our environment. I know Daniel mentioned this yesterday, that if you were looking at least for one single ScriptBlock Logging event in your environment, to look for the warning message. So what does that warning message look? It is that Microsoft has, inside of PowerShell, a list of what you can call bad words, which relate to actions inside of PowerShell that are evil. Like all of a sudden working with memory streams, or doing virtual alloc to be able to inject into a process. Because typically what we'll do is, for the most advanced users, they will not, attackers in PowerShell, they're not going to be dropping files. What they're going to do is that they're going to have PowerShell load enough code to open a process memory space, expand that process memory space, copy code into it, mark it executable, then create a thread from it and inject in memory. So no new process gets created. So Microsoft went like, okay, let's look at all of the malicious code that we have access out there. What are the key differentiators that we can find across all of this malicious code? And they created that list. And it's awesome. It really does a good job identifying stuff. And you get a 4104 like that. And again, we have other commands. If we do enable ScriptBlock Logging, and we're not going by that default, because that warning doesn't care if you have ScriptBlock Logging enabled or not. It's always going to trigger, which is awesome. I was talking with Jeffrey, and I told him, and he was telling me, what is one of the major points for attackers? And I told him, the power of default. When you start having a lot of these controls on by default, it makes our lives more difficult. Because they're on. It's not up to the users. Users tend to be lazy. Because why? Because most of this technology that we deal with is a representation of the business needs, which are also influenced by internal politics. So it's not a binary decision of 1 and 0s. It's everything very gray. So it is a representation of our organization. We can see it in the infrastructure as we're looking at it, if you want to go meta on that. So typically what most people will do is they'll enable ScriptBlock logging and not enable the start and end execution of script blocks. I was talking yesterday with Daniel about this, and I say, I really cringe as an attacker when I see that they have enabled start and stop, because now they have an idea of my tempo of operations. They know how long my scripts are running, or if they're still running in the environment, because you get that start, it started here, it did some action, ended up here. Or are they just using PowerShell for one-offs? When it runs, it goes away. And we were talking about it and looking at it that way, because you're going like, well, he has the data. Why does he care about that tempo? Because many times you guys don't ship the logs of the desktop computers back to a centralized server because it is just too much data. And what happens if you have ScriptBlock logging? ScriptBlock logging will log the first time it saw that script block, and then for the next consecutive ones, you only get a GUID. And what happens when you override that initial script block? You no longer have it. So next tip, send all of your logs to a centralized server. Because if not, I'm going to make sure that I'm able to override that information, and you're not going to be able to see it. And how do we bypass this? Well, we have two different ways. First one is this list runs in our process, so we have control over it. So I can just use .NET calls, and I can just set it to null, that entire list. So now there's no naughty word list inside of that process. Or if I want to go the low-tech route, if I do memory stream, it's going to log it. If I do memory plus stream, it's not going to log it. So it's not doing an AST examination and concatenating that stream before making the decision. So I'm still able to bypass that with just a bit of obfuscation. What is the problem? There's the Murphy's Law. You guys heard of it? There's a list called Murphy's Laws of Combat. And one of them is that professionals are predictable, but the world's full of amateurs. A professional will do that. But thankfully, there's a lot of amateurs out there that won't do that type of obfuscation, that type of research. So you're probably going like, but it's so easy to disable, I probably should not look for it. No. You don't know how many actors out there are really dumb. Where PowerShell is just a copy-paste from somebody else, and then put that extra effort. You're going to be able to catch quite a bit of people out there just by enabling that. So don't discard it just because I'm showing you a bypass. So let's look at the ScriptBlock logging of what I just ran. And, I made the mistake of not having it already pre-done in a filter. So let me go here, Application Services, Microsoft, Windows. I'm running out of time. Talk faster? There's PowerShell here. God, the font is so small. Oh, there we go. Yeah. I'm getting old. So here we see an example that it ended execution. We look at this, and the only thing it says, hey, RunSpace, state change to close. Always remember that if we go into details, we had a bit more information. Always be looking by the RunSpace ID. And also here you can see a bit more data that we can trigger on just in case as a tip, or look for the ScriptBlock logging logs. 4105. Filter current log 4105. That is 4104, right? 4104. Let's see if you guys are 04. So this script block text that you see there, it's only going to be logged once. I can run that command many times, and the only thing that you're going to be getting is this unique GUID that then you can use for your searches. So be careful to make sure that you're shipping those logs somewhere else, that you're setting proper ACLs on that event log, so the user cannot clear those, a regular user, and also make sure that you have enough space allocated for them if you have a sales or a mobile force going out there. So make sure that you follow those practices. How am I doing in time? Q&A time? Oh. 10 more minutes. Do you guys want me to go into Windows, WinDBG and how to extract malicious PowerShell code from memory, or do you guys want to go into questions? I know that that's a unique case for managing PowerShell. I can do it in the coffee break? Awesome. So one of the things that happens is that many times when we're working in these environments, we know that something is suspicious and we want to know a bit more about it. We saw that console host run, they went PowerShell version 2, and we want to know what actually is happening on that process. One of the things that we can actually do is we can dump the memory of it. And once we dump the memory, we can do quite a bit of things, because that memory dump helps me triage includes information about CPU state, list of loaded DLLs, process block environment, the PEP. One of the things that we attackers like doing is that, I don't know if you guys know this, every time a process starts, the process is the one that tells the kernel, this is my PID, this is my parent PID, this is my command line. So what we'll do is that we'll start that process suspended, we'll go into the PEP in memory, and we'll rewrite that. And all of a sudden, that command line can be whatever I want. Its parent PID can be whatever other process I want. And even the PID, I can change it, unsuspend it, and then it tells the kernel, hey, here's my information. And then the kernel goes into the auditing system and tells the auditing system, hey, log this into your logs. And all of a sudden, I just messed up with your logs in your environment. So this will actually give me the PEP, which is very nice, and I can look for some telltale signs that X amount of memory was assigned for command line, but only Y was used, which is smaller. And you're able to get a bit of more information there. Typically what I'll do is I'll open that dump. I just do open crash dump. As here you can see the information about the operating system itself. And what I like about WinDBG, or WinBag as some people in Microsoft call it, it has some very nice obscure commands that I can use. I can list all the DLLs. So I can actually look, hey, is system.automation.ni.dll loaded in memory? Yes. Are there any other DLLs that may be suspicious loaded here? Yes or no? Probably I loaded a DLL and then deleted that. I can do, I can get the DLL versions. I can save those DLL, that specific DLL, all of them, into a folder for me to examine. So even as an attacker, even if I deleted that DLL and I'm thinking I'm being a very smart ass, I'm living in memory and you cannot see me, you can still pull that information out of a memory dump. Now, one of the things that I can do is to get that data from the entire machine probably is I can use Mandiant's Memorize tool, which is very nice, and WinDBG can analyze that if I want to go all machine instead of only the process. Also, another thing in memory is get process doesn't give you command line, but WMI does, and you can automate WMI quite effectively. And if you see something like this, that looks kind of off as a command line. I know that we're going through a lot of sciencey stuff on repeated characters and stuff, but if you're starting out, just going through the basics of looking at sizes of command lines can pay dividends in many cases. And then I can use a tool like volatility that can actually get me each one of those commands that you ran inside of PowerShell, because PowerShell.exe actually reuses a lot of the code from CMD.exe. So the tool inside of volatility to get the commands that you enter in that console, I can get those. So what I did via IPC, via remote control of that PS2 session, via memory dump, I can actually get those commands that I try to hit so nefariously in the environment. Also, you can just look through your entire environment in the memory for system.management.automation.ni.dll. And you're going to be able to tell if somebody did a managed PowerShell in your environment and loaded that into it. So typically when we're dealing with WinDBG, I'll use I'll use the SOS debugging extension to be able to extract all strings out of memory. So I'm loading the extension, I'm loading SOS, MS Core works, and then what I'm doing is for each part of the heap of memory, I'm looking for system string and dumping that string into my window so I can look at it. Or one thing I can do is I can just create a script that creates a log and saves all of that stuff into a log for me to look at. Once I look into that log, as I'm moving through it, I'm going to see this. Let me see if I can get make it bigger here. So all of a sudden, do normal people use variable names like that? No. And if in your environment you tell me yes, you have a bigger problem than malicious PowerShell. Also, this looks off. All of a sudden, what am I seeing? Kernel 32 is loading virtual allo create thread. It is wait for single object. It is grabbing a lot of functions to manipulate memory. Normal people don't manipulate memory from PowerShell. So all of a sudden now I have the entire malicious payload that you guys saw me run in the macro. Now you guys can actually just pull it out of memory and track what it's actually doing, and then you see the invoke expression against that script, and you know exactly what I was doing there. So I'm going a bit further than what Daniel showed you. He showed you a solid base. What I'm showing you is those outliers for stuff to look, specifically when I'm taking actions so you guys won't see me. And that's what I want you to take out of this session. Which is upgrade to the latest and greatest version of PowerShell where possible. Test your detections. Bring in the red team and ask them, hey, I want to do a tabletop exercise. There's no need for a full-fledged pen test. You just tell them, let's do a tabletop exercise, let's simulate some attacks, and then you have somebody else going like, okay, I'm executing this type of attack. Do you saw it? Yes, no. No. Okay, let me help you tune your detections until you can detect me. Believe it or not, the purpose of the red team is to help you guys be more secure. Many times I know that we're seen as dicks. You go like, they come with their ego, they want to own us. No. My purpose in life is to make sure that you, my customer, is as secure as possible. So if you ask for emulation, I'm going to do emulation. But there are other levels of red teaming that you can ask for, and one of them is tabletop exercise, where we can do that tabletop exercise and help you fine-tune your detections. Also, assume bypasses. We're going to be doing bypasses and test if you can detect those, like monitoring the registry key for sysmon. Check that out. So this is the end of my presentation. I hope that you guys liked it. I'm Carlos_Perez on Twitter, just in case. Still have 3 minutes if anybody has a quick question. No questions? Okay. Oh, we have two. Okay. Yeah.
I just wanted to ask, you say we can take a memory dump. What if the attack already happened? Will it still be in memory?
Typically, when you're doing, you have some control that triggered that let you know that something's happening on the host. And many times you have to triage that host. And as part of triage, you can go into your event log, check if that's still running, and then you can do a memory dump to triage it in your machine. Because what happens is that typically what we do when we get into a host, we set a certain background checks into the host, looking for sysinternal tools all of a sudden being run on the host, specific processes, or we're looking for sessions that come from domain admin so we can trigger an action. And many times, what a customer will do is they'll use one of their software deployment accounts to dump the memory, get the memory out of that host remotely so we don't notice that they saw us, and then triage all of that stuff outside of the box to then come back in and just cut our access because they don't want us to know that we're there. And one of the best ways of doing it is just doing memory analysis. Okay.
I was sharing some details from our survey yesterday, and we didn't show you all the results, but one question we asked was, when you type PowerShell version 2, do you get an exception or do you see a PowerShell? And 2/3 of you said you see a PowerShell, which shows that in most default systems, PowerShell 2 is enabled, which enables something you showed.
That's why we like going after sysadmins and developers, because those are the main people that will go in and enable that in their environment. Yes?
That's why PowerShell 2 is disabled in our environment, because of this conference.
Yeah. He has a question also.
Okay, any other questions? I'd say we postpone those. And